Okay, let me continue on this problem. Right now, we understand that we are looking for the absolute minimum value of this function. So fx is 490 thousand over x plus x. And to find the absolute minimum, we first take the derivative. So we can find the critical points. Before we take the derivative, let's think about what is the domain of this function. Some students they would say the domain is from negative infinity to 0 and from 0 to infinity because obviously x cannot be 0. However, they forget about since this is a problem based on the real life, right? And in this problem, x stands for the length of this side. Therefore, it can be 0 or negative. So when we consider this problem, when we consider the domain of this problem, it should be from 0 to positive infinity. Okay, so now the derivative of this function gonna be negative 490,000 times x to the power of negative 2 plus 1, which is negative 490,000 over x squared plus 1. Okay. After we find the first derivative, we can start looking for we can start finding the critical points. So we let the first derivative be 0. We have 1 minus 490,000 over x squared equals 0. So we have x squared equals 490,000. By solving this equation for x, we can have two results. One is x equals 700, one is x equals negative 700. Because we said x can be negative, so we're gonna drop this result. So we have found one critical point. Okay, and to find another possible critical point, we look at when does the derivative not exist? Because according to the form of the derivative, we can see that it does not exist when x is 0. However, on 0, we have said 0 is not on the domain because the length cannot be 0. So even though the derivative does not exist when x is 0, but 0 is not a critical point. So we only have one critical point. We only have one critical point on the interval from 0 to infinity. Okay. Now this interval is divided into two intervals by 700. On each interval, we choose a random number. Let's see, here I choose 1, here I choose 800. And next, I plug each test point into the first derivative into the first derivative. If the first derivative is positive, then the function is increasing. If the first derivative is negative, then the function is decreasing. When x equals 1, the first derivative is negative 490,000 over 1 square plus 1. Okay. We can see this is negative. So because it's negative, function is decreasing. And when x equals 800, the first derivative is 490,000 over 800 squared plus 1. That is negative 490,000 over 640,000 plus 1. Because negative 490,000 over 640,000, this is less than 1. So when it is added by 1, the result is positive. If it's positive, the function is increasing. Because the function is before 700, the function is decreasing, and after 700, the function is increasing. So the function has a local minimum at 700. And because the 700 is the only critical point between 0 and infinity, so therefore, according to the second method, we can see that the function has an absolute minimum. The function has an absolute minimum at x equals 700. Okay, so that means when x equals 700, this quantity gonna have a minimum value. But because we're asked to find the dimension of this rectangular area, so now we have find that x equals 700. To determine the y, we can use the constraint. We can use this constraint. So y gonna be 245,000 over 700. So therefore, when we choose x be 700 and y be 350, this the amount of the fencing gonna be the minimum.